All right, so in the next few videos, we're going to be looking at a few common container types in Python. And we're going to start this off by looking at a list. So a list, the way that we define a list is going to be open and close square braces. And then you can add elements separated by commas within those braces. So this would be an example of a list. So if I were to save this as a variable, my list, if we look at the type of this, we will see that this is a list type. Now, the way to think about a list is it's essentially just going to be a dynamic container that can hold a collection of objects of various types. And the way that you grab elements from a list is using indexing. So in Python, and this is very common of a lot of programming languages, I should say. When you do indexing starts at 0. So for this particular list, we got the elements 1, 2, 3, and this will be index position 0. That's where the 1 is. Index position 1 is where the 2 is, and index position 2 is where the 3 is. All right, so if I wanted to grab one of those elements, that first element, I could say, well, go to my list and get index position 0. And get what that value is, and that's going to bring back the 1, which is the first value in that list. If I wanted to grab the thing in the second position, that'll be index position 0, 1, right? So 1 is the second position. We can grab that second element. All right. Now, in this case, we have defined a list that has all integer values, but you can have, mixed things, right? So again, just to kind of show you that, I can say, well, this my list 1, the type of that's an integer, but we can mix those types. So again, what if I redefine my list, and let's say 1, let's do 2, so I have a string in there, and then let's have 3.00, so a floating point representation. So now we have a list here. All right, and if I were to say, well, my list 0, what's in that element? And then we'll get the type of that. All right. So it's going to be an integer. If we did this for index position 1, or the second element, well, that's a string. Well, why is that? Because when we get that element, my list 1 is actually that string representation of 2. And then finally, if we were to do that for index position 2, I'm just changing some of these values here so that you can see that. All right, so that's a floating representation. All right, so I said that, when I was describing a list, I said that it was a dynamic collection. And that's important, and that's really, really useful. Because in other languages, of course, in pretty much every language, you have this notion of some type of a container that can store different values. And again, depending on the language, there's going to be different requirements. Like, in certain languages, when you define one of these containers, you have to maybe specify what the type of those objects it will. So maybe I'm going to have a container of ints, and I can only put integers in there, or floats and so forth. In Python, we have a very flexible one, and we can change the size of that very, very easily. All right, so I'm just going to go ahead and take a few of these off. So I'm just going to go ahead, restart, clear all my outputs, and just cut everything. All right, so we're back to square one here. So if I've got my list, again, we'll do that 1, 2, 3. All right, so we've got my list. If I look at the type of this, now again, it's a list. And we can actually start to get, things about some information about this list. So one function that we use a lot of time, and this is not specific to lists, but this is one of those built-ins in Python. So a list has an attribute called a length. So if we want to check the length of our list, we can use len and provide our list. And we can see that this list has 3 elements. What if we wanted to add an element to our list? What we can do is say my list, and let's say that we want to append or add the 4. Well, we can do that with an append statement. So we can say my list append 4. This operation actually happens in place. And what that means is I'm not having to say something like my list equals my list append 4. So this is actually happening on the list once we call it. And when we run it, we see we've got that 4 there. All right. So pretty much again, any type can be, an item in a list, and we can actually add new list as an item. So one of the items in a list can actually be another list, right? So if I could do something like this: my list dot append. Let's see. So we got 1, 2, 3, 4. Let's say 5, 6. All right, so I can append, but I'm appending a list here. So now if I looked at my list, we see 1, 2, 3, 4, and notice right here, it almost looks like there's a list, but we got some, it almost looks like we've still got our sequence of 1, 2, 3, 4, 5, 6, but notice we got another set of square braces. So remember index position 0, 1, 2, 3, 4. Let's see what that is. If I were to grab that, well, it's actually that list we just appended. So if I were to check the type, again, that's actually that there's a list within that list. And what if instead of doing this append, we just want to extend that list out by adding those elements? So what I'm going to actually have to do, since we've already done this append, is I'm going to say, well, this is now, let's redefine my list. Let me do restart. And we'll clean this up just a little bit. All right, so we saw when we got to this point, so we got this list 1, 2, 3, 4, and when we called append, it put this element in here, this list, it just essentially added it as an element, a single element in our current MyList object, and it was a list. What if we just wanted to essentially take the current list that we have and just add these two elements to that list instead of adding this 5, 6 as just a sub list within my list? What if we wanted to say, well, you know what, take the values here and extend my list? The way we do that is we do that with extend. All right, so that is a big difference. So append, whenever we call a list append, it's actually whatever you give it. If it's a list, if it's a dictionary, if it's whatever it is, it's just going to add that as the next element in that list. Right? If you've actually got another list and you're wanting to grow your current list to include the elements from the new list you're providing, you use extend, right? So that's extending that out. Right? So now when we look at my list, we don't have those extra square braces. And if I were to get element 4, right, or index position 4, so the thing in the 5th position, right, we actually see that we've got two different elements. All right, now just a few things to note. So in our case, if I were to look at that length again, len of my list, so we got 6 elements, and those elements are going to be elements 0, 1, 2, 3, 4, 5. That's their index positions. All right. So if you actually try to index an element of an array that's not defined, because remember, in this array, since we've got 6 elements, that's element 0 in index position 0, 1, 2, all the way up to 5. That's our last item in that list. Let me just print it right here above so you can see that. All right, so what happens if I try to grab 6? It's going to say, hey, you've tried to index an element that is outside of the range of this list. So there's not an index position 6 in this list, so you've got an error. All right, so key thing, indexing starts from 0. All right, let's look at how maybe we can grab portions of list. All right, so this is something that we do quite frequently. I'm just going to cut this cell right here. So I've got my list. We see that right above. What if we wanted to grab these numbers right here? Well, there's a slicing syntax that we can use. I'm going to show you a few different variations of that. All right, so if I've got my list, the key thing, remember, indexing starts at position at 0. So this is index 0, 1, 2. So let's say we want to grab the 3, 4, and the 5. So this is index 0, 1, and then that 3 occurs in index position 2. And we want to get 5. So we've got index position 2, 3, and 4. 0, 1, 2, 3, 4 are the ones that we want to return. All right, the way that we would do that is this. So if you've got a list, you can put a square brace at the end, and this will allow you to slice. What you do is you put the index of the first position that you want to grab. So remember 0, 1, 2, that would give us the 3. So I want to start at index position 0. Then you use a colon, okay? And you say, I want to go, you essentially have to provide at the index position just one step beyond where you want it to end, because the way that this slicing works, it starts at the first index and it goes up to, but doesn't include the last index that you give it. Right, and this is actually going to be a very common thing that we see in a lot of different libraries. So this is just kind of the norm that's used here. So remember, we want to get the 3, 4, and 5. So this is index position 2, 3, 4, and 5. So we want to grab the 5. So we need to go that one index position. So that 5th index position. So if I do that, we return the 3, 4, and 5. So I'm starting at index position 2, and I'm going to go up to, but not including index position 5, which is the value for the 6, and then it's going to return 3, 4, and 5. All right, what if we would have said, oh, well, give me index position 2 to 4, right? So that's truncating, and you might say, well, that's index, I want from 2, 3, and 4, I want those numbers in index positions 2, 3, and 4. But this syntax is going to stop one short of that. All right, you can leave off. So we were doing, starting and ending. You can leave off that ending, the second part of that colon, and that will get from index position 2 and everything beyond that. All right, so we're saying start at index position 2 and go to everything beyond that. Okay, and then you can also leave off the starting point. All right, so index position 4, let's see what this does. All right, so looking right here at my list, so this is index position 0, 1, 2, 3, 4. All right, so when we put that 4, notice it's just not going up to it because this is index position 4. So again, it stops short and it returns the numbers 1, 2, 3, and 4. All right. Some helpful things in addition to going through specifying a start and a ending, what you can also do, let's say I'm going to take my list and I'm going to go from element 0 all the way up to 5. You can provide a third argument that specifies the step size. So if I were to put a 2 here, right, so we haven't used this before, so if we do 0 through 5, this is what we get, right, with just default starting point up through location. And if we add another parameter here, this extra colon, and we put a 2, right, then we only go starting at 0 through 5, the index right before that, not including it, and then we're doing that in steps of 2. All right, so it's moving through that list in those steps. And this is all you need to kind of remember, right? So you can at most have those 3 colons. So start, the ending, not inclusive, and then the step size. All right. Interestingly, you can use this to reverse a list. So you can say, well, start anywhere, end anywhere, and then you can put a -1 at the end of that. And that's a very simple way to reverse a list. Okay, so you're essentially incrementing in a step size of -1. So this syntax will reverse that list. All right. Also, sometimes if you only care about the elements from the end of a list. So what if in this case we've got a pretty simple example, right? We've only got 6 elements in that list. So you might be able to just go through and count, or maybe what that's going to be. But sometimes you might be downloading data, putting things in a list, and you don't know how big that list is going to be. But maybe you just want the end elements. So maybe you might bring down all these numbers, sort the list. And then you might want to see what's the last, the 5 largest values. So you want to get the things at the end. Let's actually mimic that. And then we'll show sorting at the same time. So let's do my numbers. And let's say we got 1,000. I'm going to do 100,000. And in Python, you can use that underscore when you're doing an integer to kind of help you visually keep track of where the thousands place is. Let's do 250,000. Let's do 2.5 million. Let's do 3. Let's do 7, 67, 2,938. And I'll just go back through all these for consistency and put those underscores for thousands. All right, so I got a list of numbers. All right. What if you wanted to get the smallest and the largest number from this list? So maybe this is just data that you brought in. And again, this is still a relatively small example, but imagine you got thousands of these. So you bring in these numbers. The first thing that you might want to do is sort this list, right? And if you recall, when we did that append or extend, we just called list, and then we did, that, and that would affect our list. We said that was an in-place operation. Well, if you want to sort a list, you can use this sorted method. This is not a list method. We'll see that this actually works for other objects as well. All right, so if I were to get inside sorted, we notice that that's a reserved keyword. It turned to green there. Hold down Shift and hit Tab. You provide it some type of an iterable, okay? And then we'll see this key. We'll talk about that later when we look at dictionaries. And then you've got this reverse. You can make it a reverse sort or whatnot. And it returns a new list containing all the items in ascending order. So notice this, if I hit this, it returns our new list sorted. But if I actually look at my numbers, there's still the unsorted version. So this is not in place. So remember before, when we call mylist.extend, that just extended, that added those things to that list. Now when we do sorted on this, right, it's returning a new object. So if we want to save that, what we actually have to do is overwrite our list with that sorted version. All right, so we had these numbers, right? Now we've got them sorted. And let's say we wanted to get the largest and the smallest values. Well, since we sorted it ascending, the smallest value is always going to be in index position 0. So if I want to get the smallest number, I could do that. And if I want to get the largest number, if you want to, because we might not know how long this list is, right? Because again, you might be bringing in this data from some type of a database or getting it off the web, and you don't know what's the index position of that last element because it might change day to day depending on how much data you're bringing in. Well, if you want to grab the last number, you can always grab index -1. That's going to refer to the last element. So in this case, we can actually say, okay, well, this is our smallest and largest. So if we wanted to store those in variables, we could use multiple assignment. Like we've seen in the video on variables, I could say, well, this is going to be the min value and the max value. All right, so we had our list. I'm going to run them all together. So we had our list right here. We sort it. We get the min and max value. So now in our min value, we have that. And then our max value, we've got, in this case, 2.5 million. All right, so that's how we've seen how we could sort a list. We looked here at how we could do reversing. We've talked about slicing and step size. I do want to show you now, so we just showed how you can grab that last element, but you can also use this negative syntax. The last thing I want to show you, you can also use it for slicing. So for example, if I've got my numbers here, okay, and I want to, if you think about it, usually what we were doing when we were doing slicing is we said, well, specify the starting index and then the ending. So this will grab everything from index position 1 all the way through the end of the list. All right. But what if we wanted to get maybe the 3 largest values? Again, we might not know how long that list is. So specifying, if we want to get the 3 largest, okay, we want to get everything from, whatever the index position is of that, 3rd largest value, everything else beyond that. So that could be a little tricky, again, because we don't know how long that list would be. But what we can do is we can say, well, go back 3 from the end. That's essentially the way to think about that. So we can say start at -3, and that's going to essentially come back from the end of that list 1, 2, 3, and get from there to the end of that. All right, so there's our 3 largest numbers. All right, so again, in this video, we've looked at, basics of list. We saw that a list can contain, integers here, or any type of types actually. So it can be a mixture. It doesn't necessarily have to be integers or just floats. We can mix types in there. We looked at how to do the length We talked about slicing. We talked about appending to a list, extending a list. And then we've talked about sorting and how we can use, that negative indexing to work from the back of a list. All right, so I'm going to stop the video here. We will see list many, many more times throughout the rest of the videos. And we'll probably definitely see some cases that we, didn't see in this very kind of simple introduction to them. But hopefully this kind of gives you a sense of what a list is, what it can hold, how you access elements, and what you can do.